All right, good afternoon, everybody. Hope everyone's enjoying the conference. It's been a great couple of days so far. I think we're about halfway through, maybe a little bit further, but hope everyone's enjoying a lot of great talks, right? Different topics, a lot of opportunity to learn. Really enjoying all things open. And thanks again for all the organizers and sponsors for putting this together. And what a great turnout that it's been. I think I was talking to somebody that said last year was about 1/10, of course, with the pandemic, and this year we're seeing a great resurgence, which is fantastic. But the reality is, we're still on Zoom calls every single day, right? Maybe some of you are on a Zoom call right now. It's possible. And I'd like to start with a few things overheard on a Zoom call. And let's go with some groups. So product teams, security teams, and leadership teams. The first thing I heard recently was, we need to empower our developers with security. Okay? Fixing security issues in production is expensive and time-consuming. Yep. And we need validation that the products that we ship are secure. And probably my most favorite is, we need to shift left. So we will tell them to shift left. Easier said than done, guys. And realize that it's a movement. The shift left movement is fantastic. There's a lot of different pieces to it. It's very complicated. I should say there's just a lot to it. But in this talk, we're going to focus on open source security tools and how those open source security tools can really help us, when selected appropriately and implemented appropriately, can really help us to mitigate and reduce risk across our products and our systems and our environments. So that's the purpose of the talk. Let's get going with some introductions, and I want to let Zach go ahead.
Hey everyone, my name is Zach. I'm a senior software engineer at GitLab and maintainer and founder of Gitleaks. You can find me gardening in my free time, or dog training our dog Penny, guitar, going on like bike rides, camping. And I'll be talking about Gitleaks a little bit later on.
Awesome. Thank you, Zach. And just a quick introduction from me. So my name's Koehnecke, and I'm the VP of Security Engineering and CISO at JIT. JIT is a startup, stands for JIT, for just in time. We just came out of stealth mode a few months ago. We're based on Tel Aviv, Israel. I'm actually the first US employee, is the VP of Security Engineering and CISO. Thank you very much. Super exciting. I actually got to go to Tel Aviv when I started with the company. I stayed there for about 3 weeks, got an Airbnb. What an amazing place from a tech perspective. Blew me away, quite frankly. But previous to JIT, I was with KPMG, Big Four Consulting. Please don't hold it against me, but I was there for about 15 years, and I was part of our cybersecurity team. I led our cloud security compliance practice. What that basically means is we helped large organizations, Fortune 500, down to startups, to get through these rigorous compliance processes from a cloud perspective. Those of you that know FedRAMP, I'm sure many of you are familiar with SOC 2 and ISO, a lot of other global certification processes. We would come in with a team of 10, 20, 50 people and go through these long, arduous compliance processes. And again, I loved it from a consulting perspective. A lot of great success stories that we had. We like to say we were the best, cloud security compliance practice at the time. But the reality was, that I learned, is that we'd come in, we'd bring in, temporary processes, or we'd perform manual processes. Things weren't automated, and when we left, we would really stifle development velocity, right? And developers, they would come and say, what is this process you're bringing? It's not aligned with what we need to do to build our product and move our product forward. So, I realized I'm going to make a change, and the opportunity to join JIT came up, and this is where we're really enabling continuous security. And this talk, we're going to focus on the tools, right? Because it's all about automation and tooling, and the open source tools out there, which are fantastic. So we're going to go through the tools and talk about open source tools with a big focus on Gitleaks. Zach's going to touch on. All right, so kind of getting into the talk here, what are we going to do? 5 open source tools that we feel like every developer or security or leadership team member with an organization should know about. Why the tools are important, how do these tools support security, how to choose the right tools, and then how to orchestrate, triage, and manage findings from the tools. I think it's really important from a tool selection process that you build out your toolkit in a very selective way. Right? It could be, there could be times where you say, hey, well, I've got this technology, I need to run this scan, more on an ad hoc basis. The problem with that is it's challenging from a repeatability perspective and really building a security program. So we're going to talk a bit about picking the right tools. Of course, it can change as your technology changes. You need to adjust threats and risks. New tools come out, absolutely, and that'll be part of the talk as well. But it's important to have a program, and that's what this talk is going to help you establish. All right, so getting into the topics for our open source security tools, at JIT, and again, this is going to be a bit of a case study, and a lot of this happened before I joined JIT, and then I helped the team to make some selections. But the way we went through our process to select our open source security tools, we looked at these 5 areas, right? We looked at secrets detection, a huge area of risk in terms of just how easily it is, quite frankly, to accidentally or inadvertently have secrets within your code that are available to or can be exploited publicly. We'll talk a bit about dependency check, and of course, so important, have secure libraries with all of the focus on supply chain and for good reason, looking at from a dependency check perspective. Then we're going to talk about infrastructure misconfiguration, looking at, this is a huge one, right? And most of us, we try to be as much as we can all in on cloud. Realize sometimes we're stuck with some on-prem stuff, but from an infrastructure misconfiguration perspective, we're going to talk about cloud configurations. Then we'll talk about container scanning in your packages, and then last we'll talk a bit about runtime. So those are the 5 areas that we'll cover as part of this talk. Now, before we get into tools, I do want to talk a bit about the process, because I said, hey, it's very important to have a set of tools that you can rely on, it's repeatable, that you know well, it's part of your security program, your security champions or your CISO are on board, your developers like the tools. But what's the process to select? So this is what we did at JIT, is we started with this, very basic categories, quite frankly. But simplicity is important. First, looking at reliability, what we call reliability and scalability. So, you go out to dinner, what do? The first thing, I do it all, probably too much. Look at the stars, look at the ratings, look at the reviews. It's helpful, it's super helpful, right? It's not the only thing, but it's an important thing. So looking at those stars, forks, the watchers, that's really important to give you an idea of hey, what's the common consensus around these tools? Obvious, right? Also looking at called scalability, and in particular from an open source perspective. Is this tool going to be maintained, for the long term? Do we have comfort that it's going to be a tool that we can rely on, or is it going to, change the next few months or years? So that's where we can look at things like maintainability and also look at, of course, licensing. That's reliability and scalability. Then usability. This one's really important. Again, I'm not a developer, but I like to say I'm a developer advocate. But of course, hey, trying the tool, getting comfortable with the tool, your developers like the tool. There's some of these different ways you can implement the tool locally on a Docker file, different types of configuration options for the tool, and then of course, the output of the tool and kind of the user friendliness, if you will, of the output of the tool. That's an important piece. And then accuracy, obviously, last but not least, you got to make sure that the output of that tool you can rely on, false positives are just reality, but as few false positives, data that we can rely on, provides severity levels, risk rankings, and also provides coverage, across all of your environment as much as possible. So hopefully it's helpful to understand what the process we went through to help select the open source security tools. And now, without further ado, let's jump into it. So we're going to start with maybe the most important area, which is secrets detection. And I'm going to let Zach kind of jump into it and talk a bit about Gitleaks. Before we do that, just, I think you guys are familiar with secrets very much in this room, but maybe just a quick recap. Of course, any of those passwords, access keys, tokens that are inadvertently or maliciously made available within your code, within your product. And from a JIT perspective, we went through and we actually looked at, and this is going to be a common theme for this talk, but we went through and we said, hey, we want to pick the right tool for us and we think is the best for our customers. So we looked at the broader base of these different tools out there. We looked at Zach's company, Gitleaks. We looked at Detect Secrets by Yelp, and then we looked at Get Secrets by AWS. And we chose Gitleaks, and I'm very excited for Zach to talk a bit more about the product now.
Sure. So yeah, I started Gitleaks about 5 years ago. I was thinking about projects that I wanted to develop. At the time, I didn't know Golang. Searching on GitHub Explore page for projects that were similar, maybe improve upon, and I saw TruffleHog, which is another secret scanner, and it was written in Python. And I thought, well, maybe I could make this a little bit better, and also learn Go at the same time. And so that's why I made Gitleaks. Learning experience originally, learn a new language. After seeing some headlines also on developers leaking secrets, I figured this is a really important problem, and it's an interesting problem to work on. It was also really fun to develop this tool that I've been maintaining for 5 years. So it's a SAST tool, if you didn't realize that by now, for detecting and preventing hard-coded secrets like passwords, API tokens, and Git repos. It's an easy-to-use, all-in-one solution for detecting secrets past or present in your code. I think it has over 11,000 GitHub stars, millions of Docker pulls and downloads. It's used in lots of commercial products, used by government agencies, companies, all over the place. And I think it's the most popular secret scanner on the market today. And then this is just an example output of the tool. So you can use it. This is just running, let's see, on a sample repo at GitLab for secrets. And you can see there's a couple secrets that it's finding in the code. We'll go over the output a little bit later. Yeah, so one of the reasons why I think Gitleaks is popular is for following a few guiding principles. First one is it should be easily configurable. And that's achieved through a single configuration file, the Gitleaks toml, where you can define rules and heuristics for what you want to scan for. So the power really comes from finely tuned regular expressions and entropy. And there's a couple other heuristics that said you can define in this configuration file. There's a default one that exists that I think there's 140 secrets that it scans for, and then also a very powerful, generic secret scanner tool. Another guiding principle is it should be able to run anywhere. So Git hooks, CI pipelines, developer machines, IDEs, hub actions, etc. Another principle is it shouldn't be noisy, and that's achieved through accurate rules. So like I said, I spent a lot of time on these regular expressions, finely tuning them. I have a couple blog posts actually on that, which I don't know if it's linked in here or not, but if you click on one of the links on the website, you'll be able to find it. And then the last thing is it should do one thing and one thing well. So kind of following the Unix principle. And that one thing is scanning targets for secrets. Speaking of targets, there's a couple different types of scans that you can scan for. So the first one that I think most people use this is, you clone a Git repo. You want to detect if there's any secrets in that repo or not. And so you would use the Gitleaks detect command, which will scan the entire history of the Git repo for secrets. And then we also have a no Git option, and so that treats, if you're scanning a Git repo, that would treat that repo as just a regular directory. You can also point Gitleaks at specific files. Then also there is the Gitleaks protect command, which is used for scanning staged or unstaged changes in your Git repo. And so this command is actually used for the pre-commit hook, and you can use it in your a Git hook, for example. And then a feature that I just added was scanning anything. So you can type whatever you want to Gitleaks, and it will just start scanning for secrets. So this is a example output of some secrets in a repo. You can see there's the line. This is finding a Adobe client secret. It highlights the chunk of code that contains the secret, so that would be the finding entry, and that gives you context for, okay, this is the line. It also supports multi-line, but this secret is just one single line. You also have the secret, which is the good stuff, and then a bunch of other data. So like the rule that was captured, the entropy of the secret. So 3.7, that's fairly, I guess, normal range for a secret to be. You have the file, line number, and then also at the bottom you have a fingerprint. And so that's useful in case the secret was a false positive. You could just add that fingerprint to a Gitleaks ignore file, and then Gitleaks would ignore that secret moving forward for subsequent scans. And then lastly, if you wanted to scan specific ranges or by author or by dates, you can just pass a git log option. And because Gitleaks relies on Git under the hood, it accepts any git log option. And so you can use that by passing a log ops flag to Gitleaks, which will then interpret whatever git log option. And yeah, so here's some Gitleaks resources if you want to look up some more information. Gitleaks.io, there's a link to the blog that I mentioned with the regular expressions. And then, yeah, the repo, default configuration, and then also we have a Gitleaks action that you can enable on your organization or your user account, and you'll be covered for secrets. And yeah, back to you, Chris.
Yeah, thanks, Zach, and great overview. And I think you guys can see like why we picked Gitleaks between. It showed like the three tools, right? We, you know, from a reliability perspective and scalability, we really, you know, super comfortable with it, and our developers at JIT loved using it. Super user friendly and easy, and then the output, right? That was of course the biggest thing. You know, kind of check the boxes all there. So fantastic. So so let's move on to the next. So the remaining categories, and I'm going to walk through again a similar fashion, right? How we kind of went through the selection process for each area, and then dependency check. Open source software, looking at the supply chain, secure, potential vulnerabilities with those libraries. Dependency check is just so important now. Libraries calling libraries, just a really important step here. So we, of course, software composition analysis. So let's make sure that we can detect open source components with known vulnerabilities, right? We want to scan all those, all of our code, scan those libraries, and detect those vulnerabilities and make the updates where we need to make them. So for dependency check, now I think it's really important to know dependency check for Python, right? Because we looked at some different tools for different languages for dependency check, which I'll talk about. But for this one, the three contestants were safety by PyUp, Jake by Sonatype, and then OWASP of dependency check. And we chose OWASP dependency check for Python. And a couple reasons why, and to kind of go through the process. From a reliability and scalability perspective, it had all the stars, the watchers, the forks, so that, from the restaurant reviews perspective, we felt really good about OWASP dependency check for Python. From a usability perspective, there were a lot of options, that we saw from OWASP dependency check perspective. You could run it locally, Dockerfile from the terminal. There's a Jenkins plugin you could utilize as well. One of the challenges was the dependency tree. So the output, and this was less important for us for Python, but the dependency tree wasn't entirely accurate. So that's why it's in purple here on the slide. So a bit of a challenge there from looking at the actual tree within the OWASP dependency check results. But still very useful, again, for Python from a usability perspective. For accuracy, we love the fact that we had this, the vulnerability database and the open source index, like, in terms of the different, the ratings. Felt really good about that. Could also just supported the multiple file types. So again, we really like the fact that we could look at, requirements file, zip file, metadata file was all there. And then also, it's in purple here, it says multiple languages. You might think, well, hey, purple means it's not good, right? Well, the challenge that we had, and again, this is with a lot of the tools, and I talked about this a little bit earlier, but like picking the right tools for the job, right? And a tool might offer more features and functionality. It doesn't mean it's the best choice, right? So that was part of our evaluation process. So again, for our Python code, we really liked OWASP dependency check, but we're not using it for the multiple languages. And so we actually use, I think we got icons here for Nancy, we use for our Go code. So we use different tools for the different languages that we feel like are best fit based off the process that I talked about. So that's how we made the decision for OWASP dependency check. And here's just a quick example of the output. So here's a request file. Again, it's hard to read here. I'll zoom in here a second there, but OWASP dependency check is running. Here's a screenshot of the output, and here's a zoom in. And again, looking at our comfort on the output from OWASP dependency check, we can see very clearly that, hey, the source, the CVE, right, that's up there, the risk ranking, again, the score and the severity were all there, which we really liked. And then you can also see there was a link here directly to the OSS index, so we could see that. Again, not all tools do this, so it's an important step to validate and you're getting the data that you're looking for. So we like this output from the OWASP dependency check tool. All right, so coming up next is infrastructure misconfiguration. And this is a big one. Looking for things across our cloud environment. And I wish that AWS and Azure and GCP would just, out of the box, everything was secure. We all, I've learned this a lot in my career, is that be careful trusting it. There's a lot of benefits, no doubt about it, moving to cloud infrastructure, so many options and so many opportunities from a security perspective. But you've got to be careful that some of the misconfiguration isn't part of your environment. Things like missing encryption, permissions are too broad, you're not logging appropriately as a CISO. I love my logs, got to have my logs. And of course, those dreaded default settings that are making us vulnerable. Unfortunate reality, but something we have to take care of. So here are the contestants for infrastructure misconfiguration. We looked at TFSec by Aqua. We looked at KICS by Checkmarks, and then Checkoff by Bridgecrew, which is now part of Palo Alto. One thing I'll say for these tools, we liked them all, right? And all had some great features and functionality, and it wasn't a case of our team going through the selection process didn't like any of them. We just liked one the best, and that was KICS. So we chose KICS. A couple of things here, just looking at the reasons why for KICS. Again, the restaurant reviews looking pretty good. I think I'd eat here. It had a ton of stars. The watchers, the forks, those were all there. We also saw regular updates and releases of KICS as well, which gave us comfort about the scalability. From a usability perspective, we really like KICS because it handled the multiple file types. That was a big bonus there. And also from a queries perspective, we could run a lot of different queries because of all the different checks that are out there for KICS. I think there's over 2,000 different checks that KICS does for infrastructure misconfiguration, which is really, really powerful. So we really like that with KICS. And then this, also from an accuracy perspective, this nightly build. So those checks, 2,000 checks, and they're being updated on a regular basis. We'd see this update on a nightly basis, which was great. We did notice one quirk, and I'm not sure if this has been fixed yet, but there was a couple times when we ran the scan, it said it completed successfully, but then we went back to look at the results and it said no file scanned. It didn't really run successfully. So we had to go back and make some tweaks and changes just to make sure that the scan ran appropriately, but that was relatively minor, and we worked through that. But a few kinks along the way, it happens. So that was infrastructure misconfiguration tool selection. Here's a bit about the output from KICS. So for this, you can see that for this example, we've got within AWS, we've got an EBS volume that's showing unencrypted, and so KICS ran, and we can see from the output of KICS, it actually called the severity of this unencrypted volume that was detected as a medium. I don't know. I think if I love my encryption, I'd probably put this as a high and then downgrade it. But that's my opinion. But KICS rated it as a medium, and it also gave some specifics here around the issue, right? Talking about, hey, this EC2 instance supports encryption at rest, and then it was encryption was not enabled. So pretty straightforward example here, but we liked that it gave us this level of detail, right, as the output from the KICS scan. So that was good. Here's just a zoom into that, right? You can see a little bit easier to read that this is rated medium and some of the details around that. All right, so next up is container scanning. For container scanning is, of course, to detect vulnerabilities and configurations issues in our container images. We love our friends from Slim AI who are doing some great work here to help us with this mission. And our contestants container scanning, Trivy by Aqua, Claire by Quare.io, and then Anchor were the three choices. And we chose Trivy. And again, restaurant reviews looking solid, a ton of stars, the watchers, the forks, all looking good there. From a usability perspective, I talked with my developers about this, and they said, hey, it was just easy to use. Like, they had scans up and running within minutes using Trivy. So it was very, very simple install process, and just to go ahead and just install, start running against our containers. Very simple process for us to be able to go ahead and do that. We also like the fact that Trivy would handle multiple OS packages, so very versatile in terms of what the different containers that we could scan. But then again, a bit of a negative is that, maybe not negative, but we didn't want to use, is Trivy also provided additional features and functionality, secrets detection, and infrastructure as code scanning. And I think that's an important part as a security professional is, more is not necessarily better in terms of running the scans and getting the results. So for us, we turned off the secrets detection because we're already using best-in-class and Gitleaks. And from an infrastructure as code perspective, we're using KICS I just talked about, looking for those misconfigurations. We don't need to run multiple scans and get the dreaded duplicate finding, right? Not a lot of fun. So we turned that off, just focused on Trivy for running container scans, and we were happy with the results. Here's just a quick view, and again, very simple from the output of Trivy. You can see the specific library that was scanned, the CVEs that came up, that were part of the, that were detected, the risk ranking, which is critical, and then some of the additional information about each one of those vulnerabilities. So give us enough to act, right? Is what we're looking for with these open source security tools. All right, so now we're at our fifth category, And this one is, of course, last but definitely not least, with runtime scanning and looking at DAST, right, dynamic application security testing. Let's detect vulnerabilities in web applications and APIs while they're actually running, because of course we're doing everything we can to shift left and to detect those vulnerabilities, detect those vulnerabilities early in the process. But we need to have those runtime scans, right? Because there's going to be things out there that we just that we may miss or may be only detected as part of runtime. Whole point of DAST, right? So for our runtime scanning, we looked at 3 tools. We looked at OWASP ZAP from our friend Simon Bennett's, which I'll talk about here in a second, Nikto, and then Arachni. And I think I actually have a note here that I think Arachni has actually been deprecated now. It's actually not open source anymore, which made it a little bit easier for us to choose. Gets into the scalability selection process. But for our runtime scanning, we chose ZAP. And again, if you look at the restaurant reviews, right, the reliability, oh my gosh, a lot of stars, watchers, and plenty of forks. So we felt really good about that from a community, open source community perspective. Super solid. If you use ZAP, it's fantastic. The founder of OWASP ZAP is a gentleman by the name of Simon Bennett. If you're familiar with ZAP, you probably know Simon. Simon actually just joined JIT a couple months ago, so he joined our company. We're super excited to have him on board to help us to enable ZAP scans. And kind of getting into the reasons why we selected ZAP, again, super user-friendly, right? We could run it locally, Docker file, there's a lot of different options in terms of running ZAP. And then this term very, very extensible, maybe too much of a good thing in some cases, but there's so many features and functionality within ZAP, different ways you can test. It's a great tool for penetration testing, right? Where you can, some of the different options as you find out more about an application, you learn more about how it behaves. ZAP gives you a ton of options to be able to, to run and get more specific with your testing, which is great. From an accuracy perspective, I just talked about the features, all these different features that came back that gave us a lot of comfort around. We'd run the different tests and the results were accurate, so we felt really good about that. And then all these different things we could do: SQL injection, broken access, cross-site scripting, fuzzing, all these different different types of tests that we could run with ZAP. Really good. Fantastic tool that the reason why we selected. And here's just a quick view of the output from ZAP. We can see in this example it's showing the content policy header was not sent, so it says specifically what the alert was. You can see the risk ranking that's on there as well, and then some details around the actual vulnerability, within the actual scan results. So all the data was there from an accuracy perspective that we wanted to see to help us make risk-based decisions about what we need to fix, prioritize, things of that nature. All right, so that was the, hope you guys enjoyed that and kind of got a glimpse of the process that we went through to select our open source security tools, right? Again, we champion open source. Our product, JIT, is actually, it's free. Encourage you to take a look at it. I talk a bit about it, how we orchestrate this. But if you look at, I touched on some of these tools up on the screen here, but there are so many great open source security tools out there, and just urge you to take a look at them. We feel like we're at the All Things Open conference, but we feel like this is the future, right? The future's now. But in terms of the security tools, best in class, open source provides that kind of the think tank, if you will, the global think tank, for us to be able to really understand vulnerabilities and not get stuck in some of the silos some of these products get stuck into. So we're super excited about all the products here on the screen, especially Gitleaks. But we like them all, and just want to talk a bit about we're running all these scans. I recommend pick your toolkit, right? Go through and select your scans and be methodical about it, understand and try to be consistent as you can. It's going to help your developers to get comfortable with the tools. It's going to help your security team because they're going to understand the results. They're going to have comfort in the tools, all those good reasons, right? challenge can be, of course, if you're running all these different tools, how do you orchestrate all of the scans? How do you handle all the results? I mentioned let's avoid duplicates. Let's try to, as much as we can, avoid false positives. It's just reality. But how do we kind of take all of these scan results and orchestrate them in a way where we can run the scans consistently, and we can see all the results in a single pane of glass? And that's exactly what we've done at JIT. So a bit of a shameless plug here, but in terms of enabling the different security tests, what I talked about within our product, you can go to jit.io. It's super easy to sign up if you're on AWS, even if you're not. If you're using GitHub, highly encourage you take a look. Integrate your platforms, super simple. I mean, it couldn't be any easier to set this thing up. Once you do, in a few minutes, you can turn on these scans. I talked about all these open source because it's free, it's fantastic. Scanning your code for vulnerabilities, scanning code for hard-coded secrets, all these things you can enable within JIT at a click of a button. So once you've set up, which takes about, 5 minutes to integrate your environment, and you can pick and choose which repos. You don't have to bring in everything. You could do some test repos if you want to be comfortable. But you could orchestrate all these scans through our user interface. You can enable them. And then once you enable them, they run with every pull request, which is fantastic. Or with the example of the ZAP scans, they'll run daily for you. So we'll run those scans on your behalf. We either run them from our cloud or within your environment. So once you turn it on, you're good to go. And then I think what's really great, and again, I'm not a developer, but I love this feature for my developers, is to have this dev native experience within GitHub where you can see the comments. So as the open source tools are running within your environment, you can see specifically, hey, JIT ran this scan, detected these vulnerabilities, and your developers can see it right there. And they can decide, hey, this is something we already knew about, it's a false positive, we can ignore it. You can, of course, you can roll that forward, or, oh my gosh, yes, we need to action this. So it's not just in a dashboard somewhere as a security guy like me. I love my dashboards, right? But you can actually see within the PR comments within GitHub, you can see that it's running, you can see the results, and it has that kind of interaction. JIT runs as a bot, so you can see it running, and you can interact with JIT that way, which is fantastic. And then I talked a bit about, you have to pick your toolkit, you run all these scans, but then you're going to get all these results back, right? So be careful what you wish for, right? But it's important from a security perspective to detect these things. But you got to make risk-based decisions, right? From a security perspective, and how do you decide what to fix? And one way we look at this from a prioritization perspective is to look at per PR, so per pull request. Within JIT, you can see specifically how many PRs are being monitored, how many have open findings, and then how many have been fixed. You can see, hey, are these findings slowing us down, or is there potential for a PR that's stuck in security findings? You can see it within your JIT dashboard, which we really like. So it helps us to prioritize things, right, in terms of the vulnerabilities, which we really enjoy.